All right, so we have a bag that has 9 red marbles, 7 white, and 7 blue. It says you draw 4 marbles out at random without replacement. What is the probability that they are all red? So in other words, the first one you draw is red, the second one you draw is red, the third one you draw is red, and the fourth one you draw is red. Now, what you have to do is you have to think about, so for this, I can see that I have 9 red, and notice it says without replacement. So once you pick one of these, okay, you don't put it back. So there were 9 red, meaning 9, and now when I took that one, there's only 8 red, and then only 7 red, and then only 6 red. To find probabilities, we are going to multiply these because we're going to say the first one's red and the second one's red and the third one's red and the fourth one's red. And remember, and means to multiply. But what are the actual fractions? Well, we want to think about that we have 9 red, 7 white, and 7 blue. So if we added all of these up, so 9 red, 7 white, sorry, it's ugly 9, and 7 blue, you would see I have 23 total. So if I've taken the first pool, there's 23 total marbles. Then there's 22 because I pulled a red one out, then 21, and then 20. And if you just throw this in a calculator, you get this big old fraction, 212,520, which gives me this decimal. All right, now that one's pretty easy because there's only one way that can happen. This one is the problem because now it's saying what's the probability exactly 2 are red. Well, couldn't you have a red, and then we don't know what color this one would be. We would just call it a not red. So white or blue, and then also a white or blue. So that's kind of the problem. Oops, I can't grab that. But I'm going to undo that anyway. That's kind of the problem with this. So what you have to do, and let me move this out of the way, you have to figure out every combination that you could actually get 2 reds. So I'm going to use R for red. So I could get a red, and then I'm going to use NR for not red. One thing that could happen, I could get a red, a not red, a red, and a not red. Okay, trying to keep those kind of more together. I could get a red, a not red, and then a red. I could get a not red, red, not red. I could get a not red, a red, and a red. And I could get a not red, not red, red. All right, so this is kind of important that you can see, and let me circle these so you can kind of see where the reds are, that there are 1, 2, 3, 4, 5, 6 different ways that this could happen. Now, if you sit and you write these probabilities out, and I'll do a couple of these. So the first one's red, so 9 out of 23. The second one's red, there's 8 red out of 22. Now, not red, what did we have? 14 that are not red, and now we're down to 22. And then we have 13 not red. So in other words, we pulled a red, a not red, and not red. And so they're going down. If you set and you did all of these, so red, not red, 14 over 22. Now a red, so that goes back to 8 out of 21. And then a not red, 13 out of 20. If you sit and did every single one of these probabilities, you would see, because remember, multiplication, it doesn't matter if you multiply 9 times 14 first or 8 times 13, because you're going to multiply all the top values and all the bottom values. All the top values will always be these numbers. And if you don't believe me, you could sit and actually multiply you could write every single one of these probabilities out. The reason that I don't, because I know there's 1, 2, 3, 4, 5, 6 ways that this can happen. When I multiply one of them out, then I just simply multiply this by 6 and I get 0.36996, or in this case rounds to 0.3700. Okay, but it's understanding that you can write out each one of those probabilities. Now the last one, none are red. That's pretty easy because that means not red, not red, not red, and not red. If you're kind of getting what's going on, 2, 3, 4, I can write all of these denominators, right? Because we start with 23 marbles, then we get 22, 21, and 20. And not red, we have 14, 13, 12, and 11. And if you throw that in a calculator, you should get this value. One thing back up here to mention is, remember when we're multiplying, that's and. So this first thing could happen, or, and that's why we're adding. The second thing can happen, or, because remember in probability, or means to add.